My name is Oscar Mur-Miranda. I'm a faculty in electrical engineering and computer science, and I teach at Olin College of Engineering here in Needham. And Olin is a school that is a very small school. It's relatively new. Started in 2001. We had our first class, and we're focused on transforming engineering education and changing the way we teach engineering in various ways. So we have redefined engineering from the narrow slice that historically has been engineering, which is the technical part, just do the math and build something. And we've redefined that to say that engineering starts with people and ends with people. What's important is that that recognizes that the engineer, in order to be a good engineer, not only do you have to do the math and science correctly, you have to understand the user. That means humanities, liberal arts, ethnography, all these other parts of knowledge have to be present so that you understand the context that you are working with. Historically, the idea of engineering being a technical thing and a gadgety thing meant that you had to be attracted to the machine or to the mathematics by themselves out of any context. Well, turns out that, first of all, that's not realistic because engineering occurs in a real context, and that many individuals are more attracted to a wider array. So whereas you have other individuals that might not be necessarily attracted to the mechanical part or to just the pure maths, not because they cannot do it, but because they don't find meaning in it, they will instead say, this makes sense for me to do because I know the people that I'm affecting. I can understand engineering not as usage of science and technology, which it is, but as a way to have real impact in the lives of people. At Olin College, we have been successful in attracting a wider array of students because they see that when you come to Olin College, it's not about just the doing and the math. That is part of it, but there's a lot of teamwork. There's a lot of reaching out, talking to the community. There's a lot of studying different fields, talking about business, talking about design process. The student body that we have at Olin, it is fundamentally very diverse. And that means that we actually get a lot of students that are not necessarily from the outset convinced that they wanna do engineering, yet they come to an engineering school. Not only that, we have a lot of students, and especially women, underrepresented minorities, that come here and they don't identify themselves with the label of engineer. And they said, I'm here, I don't know why I'm here. And there's a very strong answer to tell them, look, you're gonna learn to be an engineer here, but you're not gonna be an engineer. You're gonna be whatever you want to be. And that's very powerful because the idea of being an engineer doesn't have to define you. You define yourself. And in a sense, we are redefining engineers. So maybe the label has to change, or maybe the understanding of the label has to change. The Affordable Design Entrepreneurship Program at Olin is a capstone program created by Professor Ben Linder. And it is cross-college. Students from Babson and Wellesley can come in, and when we create these multidisciplinary teams, the purpose is to solve poverty, to have impact in issues of poverty using this broader definition of engineering. So we employ both the humanities and the business part. Our students work together. They also do co-design, where they engage the context in the design process, and they do so in international context. They go to Ghana, India, Tanzania, Brazil, Morocco, and they address different problems. They actually travel there and interact with the community in order to become better designers. A central idea of our redefinition of engineering means that design thinking is the central part of being an engineer. All of science and mathematics and all other areas, domains of knowledge, serve the design process so that you can get from people to people. In order to be a good engineer, you have to be able to identify those pieces that are part of you, but that necessarily constrain the way we see reality, so that you're able to hear the other person and see what they're trying to offer as much as possible without your own biases. Design thinking intentionally has a lot of tools that are there for the explicit purpose of people to really park or become aware of their own biases. If we had just a group of students that had the same background, the same way of thinking, yeah, maybe the design process would allow them to park and become aware of their own biases if they were really, really good. But you don't have anything to fill that vacuum with. And that's where diversity comes into play. If I can park myself out and I can adopt your values, then my way, my ability to see will become much larger. Insofar as I'm able to hear and communicate with somebody that has a fundamentally different view of life, that means that I can use their lens, and it's sort of opening the amount of things and the amount of possibilities that we can find in terms of design. One good example of diversity challenging our work as engineers occurred when I was with a team in Ghana. And our team spent several days designing a connection, and it was an electrical system to connect a battery to cell phone chargers. That was the main product. We were biased, and we had a problem because we brought our soldering irons to make those electrical connections. We found that in Ghana, there's essentially not that many soldering irons. It's just not something that is just out there. We were struggling with this. We went to a village and presented our device. I think that afternoon or the next day, a man from the village came to us with an exact replica of our machine. And he had constructed everything, absolutely everything, with things that he had found around. Specifically, he wasn't able to solder. So he did something that, again, in retrospect, he crimped. All the pieces of metal that he had little crimping areas, and you just put the wire and crimp. We know how to crimp, but we think of crimping with like big cables, like the battery cable, and we don't think crimping of small cable. Why not? That's the right solution. We could not see it. It took diversity to really see a fantastic solution.